71. Let's read the question. Alkyl fluorides can be prepared by. The given options are Schwarz reaction, the next is Hunts-Dicker reaction, the next option is Finkelstein reaction, and the last option is Corey-House reaction. Class, this is a very important question, as we all know that Schwarz reaction is a very important reaction which is used for the preparation of alkyl fluorides. In this reaction, alkyl chlorides or alkyl bromides react with metallic fluorides to give alkyl fluoride and AgCl. Class, in the place of AgF, we can also use COF2, or we can use SbF3, or we can use Hg2F2. Class, Schwarz reaction is an example of halogen exchange reaction in which chloride or bromide are substituted by fluorides. So, the correct answer for this question is option number 1. Let's move to the next question, students, which is 72. Let's read the question. In a group of isomeric alkyl halides, the order of boiling point is. Class, in this question, we are given with isomeric alkyl halides. One is primary, one is secondary, and one is tertiary. And we have to identify their correct order of boiling point. For this question, we need to know that on increasing surface area, boiling point also increases. Class, as we all know that for isomeric alkyl halides, primary halides will have more surface area than secondary halides, which ultimately have more surface area than tertiary halides. That means the order of boiling point will be same. That means primary halides will have higher boiling point than secondary, which ultimately have higher boiling point than tertiary halides. So this is the order of boiling point. Thus, this is possible for isomeric alkyl halides. So the correct answer for this question is option number 3. Let's move to the next question, students, which is 73. Let's read the question. Thus, in this question, we are given with an aryl halide and alkyl halide, and these two reactants combine in the presence of sodium and dry ether, and alkyl benzene is formed. And we have to identify the name of the reaction. The options are Wurtz reaction, Fittig reaction, Wurtz-Fittig reaction, or Sandmeyer's reaction. So class, this is a very important question, as we all know that this is Wurtz-Fittig reaction. This reaction is used to prepare alkyl benzene using alkyl halide and aryl halide, and these two reactants combines in the presence of sodium and dry ether. So the correct answer for this question is option number 3. Let's move to the next question, students, which is 74. Let's read the question, students. Among the following, which one has the weakest carbon halogen bond? The given options are benzyl bromide, the next is bromobenzene, the next is vinyl bromide, and the last option is benzyl chloride. So class, let's start with option number 1, which is benzyl bromide. In this case, carbon is attached to benzene, which is further attached to bromine. Let's draw the lone pairs of bromine. Students, it is very clear that in this case, the lone pairs of bromine are not participating in resonance. Let's move to the next option, which is bromobenzene. Students, in this case, the lone pairs of bromine will participate in resonance. As a result, the CX bond in bromobenzene will acquire some partial double bond character, which ultimately increases the CX bond strength. Let's move to the next option, which is vinyl bromide. Let's draw the lone pairs of bromine. Students, in this case also, the lone pairs of bromine will participate in resonance, which ultimately give rise to partial double bond character. As a result, the CX bond strength will increase. Let's move to the last option, which is benzyl chloride. In this case, carbon is attached to benzene, which is further attached to chlorine. Let's draw the lone pairs of chlorine. Students, in this case also, we can see that the lone pair of chlorine is not participating in resonance. As a result, we can clearly see that only we have to compare between option number 1 and 4, because in case of option number 2 and 3, the CX bond has partial double bond character, and because of which the bond strength of carbon and halogen has been increased. So class, now let us compare between option number 1 and option number 4. In the very first option, the CBr bond length is longer than the CCl bond length of option number 4, because the size of bromine atom is larger than the size of chlorine atom. As a result, we can say that CBr bond in benzyl bromide is weaker than the CCl bond in benzyl chloride. As a result, we can conclude that the weakest carbon halogen bond is present in benzyl bromide among the given options. So the correct answer for this question is option number 1. Let's move to the next question, students, which is 75. Let's read the question, students. In this question, we are given with a Grignard reagent and phenol, and we have to identify the product, and we are given with 4 compounds. So let's see what happens when Grignard reagent reacts with phenol. Students, as we all know that phenol is acidic in nature. This hydrogen is acidic hydrogen. When phenol reacts with Grignard reagent, which is RMgX, acid-base reaction takes place, and the aryl part of Grignard reagent takes the acidic hydrogen of phenol, and benzene is formed. Along with that, the side products are formed is phenoxide MgBr. So we can say that the correct answer for this question is option number 2. Let's move to the next question, students.